You can pass that on. Might be a little easier to understand that way. I don't know. It's just kind of funny.
On a scale of 1 to...
That's like stuff on the board to like remember the elements.
The periodic table?
Yeah,
Uh-huh.
something like that.
Ron, on a scale of 1 to 10, what's your favorite color of the alphabet?
Got it right away.
Yeah, I didn't get a scale.
Favorite color of the alphabet, huh?
Yeah.
I didn't get a scale first.
I love doing that because either like they overthink it, like you guys were doing it,
Yeah.
or like just like catching straight. I'm like, wait, what do you mean? Or they just get straight confused. Sometimes most people like if they already know what I'm doing, they'll just go along with it and say random shit like me. Like I'll say I saw these triangles. Like, oh yeah, I like red wheels. They're nice. Trapezoids are pretty cool.
Okay. Let's go through this finish this chapter, I should say. We haven't progressed too far. We got a long way to go.
I don't get it.
You don't get it?
I don't get it.
Let me see.
Seriously?
I'll help her
Oh,
out.
the picture?
Oh.
Obviously joking.
Oh.
Oh, that's
One of
why
the
you
two,
can't see me laughing. I forget
Yeah.
that I have
Yeah,
that.
see? We can't tell what you're
Question,
saying.
because I've been genuinely curious since the day I met you. Do you just wear the mask because like you're a germaphobe or something like that, or like I was like you just prefer to wear it?
Yeah, prefer.
Okay.
Prefer. I'm not a germaphobe, even though COVID kind of enhanced my
Yeah.
ickiness that I already had.
Exactly. Okay.
But, you know.
I was like, you look like a mask over there, because you used to wear your hoodie up. You had your hoodie up.
Oh yeah, I scared the
Head
crap
wrap,
out of people,
this,
especially going
like-
into the store.
Yeah.
Man,
I see you with your glasses,
Look like a
mask,
hitman.
I'm like, what is
And I
she
come
doing?
in, and I walk into, you should see like people get scared, shit, like security's all like,
Oh, what's she doing?
you know, what she, you know, like, and I'm just like,
That's
And
all
y'all-
today.
you know.
Okay?
I thought maybe
Next
you
one,
had-
hope to push one amp through one ohm of resistance. He's trying to keep him from getting through that, right? So that's how kind of
No, I
flow
just-
goes, right? You voltage, grid current, and your resistance.
Yeah.
Like I'm an avid hand washer, so it's
Yeah,
like,
Every time you enter the room, you get hand sanitizer.
Almost,
Before you
almost.
sit at the computer, hand sanitizer.
Oh,
Your
yeah.
hand sanitizer
or I
don't
have it in my
work.
purse.
Huh?
My hand sanitizer don't work.
This
Can you
one?
use it?
Yes, it does.
Oh, the one in the, oh, you use that one?
This one works. I don't like this one because it's
That
like
was
gel.
Yeah, that one,
It's
that
like all
one's,
sticky.
Yeah, yeah, get my hand on.
You gotta sit here and rub it in for like 2
Yeah.
3
That's
minutes.
nasty.
I don't mind using it. It's the same thing. I just don't like how like jelly it is. It's
yeah,
weird.
this one here is not very good.
It's like anybody
Too-
got like
too
younger
thick.
relatives that like ever made slime. My little brother, he wanted to make slime out of that like
I
blue bottle and
refuse.
shit.
No.
So I helped him with it, but it came out terrible and runny. It's like it feels like that, like just water
You
and
just feels,
sticky.
it feels like snot. Just, it feels like snot.
I've
feels
never
like
rubbed
snot.
snot between
Yeah.
my hands on
No,
so
it's-
I can't say.
All right,
So-
we're ready to go.
Yes, now we're on the quiz.
No, we haven't finished.
No, we still
We never finished it.
Oh, we did.
We're on series parallel circuits.
Yeah.
That's a combination of the two, right? That
We
just
still got
makes
another
sense, right?
page or 2 pages.
Series parallel circuit's a combination of a series and a parallel segment into one complex circuit. Two different types, circuit with a load in the series with the other loads in parallel. The circuit with the parallel circuit contains resistors or loads in series with one or more branches, kind of like this. Series parallel circuit.
The question that I have with this is, because I'm seeing on page 477 and 476, the equations here.
Yeah, we're not gonna go through all of those.
Do we need to know any of it for the?
A little bit, I'm gonna show you the basic stuff, what you're gonna kind of need to know, okay? To make it as simple as possible. Key to solving these is to combine and simplify. So what you're gonna do is, we'll get to a couple of them. But again, we're not gonna do them all, because we just don't have time, and you don't need to know how to solve every one of these circuits. You have to know basic Ohm's law, how it works, how it applies to the car, and how it would help you diagnose electrical problems, okay? For example, if there's two loads or resistances in a series within a parallel branch, then the circuit can be made simpler if the first two are added together before attempting to solve the parallel section, which we'll see in a minute. Okay, this is a series parallel circuit, right? It's a combination of both. It's super easy to figure out because of what you already know. What do you think?
So it'd be R1 plus R2, right?
Where are we from?
It would be a
One,
4
one,
and
two,
4,
eight.
4 ohms
That'd
plus
be
4
10.
ohms.
10
What's,
ohms.
tell me what the total resistance of this circuit is.
Altogether?
Set the resistance?
Total
What is-
resistance of the circuit. You don't even have to do
16?
really anything to
4,
figure,
isn't it?
all you have to do is look at this and this.
And wouldn't it be 4
What's the
ohms?
total resistance of the circuit? It has to be 4 ohms, doesn't it?
Yeah.
How do you get 4?
You gotta add 4 and 4 together since
These
we're
two
on
are
the
in
same
series, so
circuit.
this becomes 8, right?
Yeah, and then you divide
Now
8
you
by
have
2.
two 8s together, that
4.
becomes 4.
But why does it say on the bottom, the,
R plus.
I don't understand why it
R1 plus
has
R2
the-
because R1 and R2 are on the same circuit line.
I know, but why does it have that there, like, why is it?
Just to help.
It's just
It's
reference.
just like the formula, like if you, on a math worksheet, it'll have on the top of it, it's what you.
Right, I don't know, I guess because we already know, so I don't know.
You
They
overthinking
trying to make.
I-
So resistors in a circuit are gonna be labeled R1, R2, R3. That just means resistance or circuit load 1, 2, 3, okay? Easiest way to do this is just like we talked about. These two are in series, so you can add them together. Once this is 8, you can get rid of this and this, right? 2 8s in parallel, you know, make 4, right? The 4 works for this, right? 3 times 4 is 12. Works for your Ohm's law formula, right?
Is there a video of it?
What's that?
Are there videos or something like this? That they're showing on your vehicle or something like
Is there what's on this?
He wants to see a live action of like,
that? Is there like videos of them showing you?
like a teacher doing math on
Oh,
a
circuit
video.
solving
No,
for
like,
YouTube
like-
videos? Absolutely there is.
no.
Yeah,
I think,
there's tons of
I
them.
feel like on a car, it is.
We can't see it.
No, you can't see that.
Yeah, you can't.
You can check the volts. but-
Yeah. The only way you can do it is with a meter, testing it. We'll get to
And
that.
it'd probably be more confusing on a actual video of them testing because they're not built like that. They're just strands.
Another simple one, right? It's a series parallel circuit. It's a combination of the two.
Mm-hmm. 4.
You know how to easily solve this circuit, right?
4. So that one up there is 2. 4 divided by 4.
What are we trying to figure out? We don't know the resistance of R1,
Yeah,
right?
2.
No. Is it?
Look, first of all, 12 volts, 3 amps. Divide that. That's 4. Okay.
That's it.
And then look, 2 or 4 and 4. You gotta divide that by 2 because there's 2 of those. That's
Yeah, that
2.
is 4, yeah.
So up there
4
is 2
times 3
because
is
2
12.
plus 2 is 4.
Or 4 times 3 is 12.
The question, R1 should be 2.
Or you can just put another 4 there because 3,
35.
4, 12, whatever. is-
4 times 3 is 12. 'Cause you
Yeah.
can do it like that too.
By the way, I'm not saying it was 2 all around. I'm saying the question mark is 2. That's what I was looking for. Yeah, the missing ohm that we're looking for, R1 is 2.
This is the question in the
So
circuit.
altogether
They
it'd be
want to
4.
know what the value of R1 is.
Yeah,
It's simple,
2.
right?
See somewhere.
Why is it simple? Because you still have 2 known values.
Yeah.
You use Ohm's law.
12 divided
You
by
know-
4 is 4.
The total resistance has to be 4 ohms. You know if you have 2 4 ohm resistors in parallel, it becomes 2.
Yep.
What's it gonna take to make it 4 in a series circuit? Because now it's a series
2.
circuit, because you just got rid of this,
2.
right? 2, 2, 4, right? Okay. Hopefully. Okay.
I got a question.
Because we can go through a million of these, I'm just not gonna do it because it's just 2 times too many.
I got a
We
question.
need to move on. Yeah.
When we take that test, is it okay if I have a sticky note with the I, E, and R just so I don't forget?
Or you can leave it on the floor.
Or that, yeah.
Yeah, of course.
Thank you very, very much.
Yeah, I don't.
Maybe a brighter pen.
Use the green one. The other green one.
I'll use the one that shows up better, how about that,
But
yeah?
I mean like how you have it up there, the I's, amps, E's, volts,
Oh, we
R's,
can leave that
resistors.
there?
Yeah, that can stay there.
Please and thank you.
This should be a better E though, right? And then you know what these are?
Yeah.
This is watts equals volts times amps, right?
I remember resistance and ohms, so I just mix up amps and volts.
Okay, where are we? I'm all mixed up here. We're on 41, right?
We finished that, yeah.
41, okay, here it is. I got a whole bunch of stuff here that's confusing me. Ton of work to do. Okay, 41.
Why is it a
Did I
lot?
give you two of them? Felt like two of them.
Yeah.
Okay, pass one back, would you? Here you go, Joe.
Okay. Alright, let me go get Tony. Fine, Tony.
Soon.
It's not working?
Yeah, it's dead. I don't know why, the rest of the classrooms are good, I just checked them. This is the only room that's,
CDL ain't here today.
Is that an open circuit?
what's that?
Is that an open circuit?
It's an open circuit,
It's
yeah.
not reaching here?
Or no power, yeah, one or the other.
Are you at 7?
I'm on 6.
Bless you.
Is it easy?
Somewhat.
Nothing to it? Anybody having trouble?
Yep.
Okay, well, let's go through them and we'll find out who's having trouble and who's doing what and how we figure it out.
I think I'm wrong. But which of the bulbs in the circuit will drop the most voltage? Is it bulb 3?
He says it's 3. How many like that
I
answer?
might be wrong.
Tell me why.
It's the biggest
It
number.
has the most ohms, the biggest resistance.
Because it has the highest resistance, right?
Yes.
Okay.
So am I right?
Bulb 3 is correct.
Okay.
The 6 ohm bulb is going to have the highest voltage drop. Now remember, if you calculated the voltage drop on this one, and this one, that voltage would equal 12. If you did the math, okay? Which would be what? 6 divided by 12, 4 divided by 12, 2 divided by 12, so you'd have 6 here, 3 here, 4 here, or 2 here. It would come up to 12, all right?
What was number 1?
C.
Bulb 3, the one with the highest resistance is going to have the highest voltage drop. Okay, 2.
In a series parallel circuit, how is the total resistance in the circuit determined? I said B.
You said B. How about you? What'd you get? What'd you get?
I just put A. I mean, I'm assuming it's B, but I
What'd you
can't
get,
figure out
Charles?
which is which.
Yeah, B, actually, B too.
Okay, what'd you get, Nasser?
I got B too.
You got B? How about you?
D.
How about you?
A.
How about you? Okay. They're all wrong.
Dang.
Tony has left for the day. He had to go to
I
DMV.
figured that.
He went to DMV, so he's out. I don't know.
I guess we'll just have to deal with it.
Yeah, I turned this one on out here, so hopefully that'll help circulate through.
Okay.
Sorry,
thanks.
guys.
It's all right. The voltage drop in each branch of parallel circuit is what?
We have 3?
We're on 3. Charles, take it away.
C.
No.
B.
B.
No.
What?
Equal.
Yeah.
Oh,
Voltage drop.
Parallel.
Parallel circuit. Number 4. Ask her, take number 4.
Hold on.
What's up?
Hold on. Varies depending, I thought it varied depending on the resistance in that branch. It says a parallel circuit is a complete circuit. The current flow through each branch or leg varies depending on the resistance in that branch. A break or open in one leg or section of a parallel circuit does not stop the current flow through the remaining leg of the parallel circuit. So the voltage drop for each branch of a parallel circuit from on page 472 where it says parallel circuits, that's why I said none of these, because it says that it varies. So what am I missing? What am I not understanding? Because a parallel circuit is a complete circuit that has more than one path for the current. The separate paths that split and meet at junction points are called branches, legs, or shunts. The current flow through each branch or leg varies depending on the resistance in that branch.
The current flow varies, not the voltage drop.
Oh.
It's asking the voltage drop.
Oh.
It's equal.
Okay, that's what I was missing. Okay. So where is the voltage? Where does it say?
Yes.
Battery.
So then I will go, okay, so then that's where the walls would come in, parallel circuit walls?
Yes.
Okay. So the voltage is the same for each leg of a parallel circuit?
Yeah, the current varies depending on the resistance.
So the voltage drop for each branch of a parallel circuit is equal?
Okay.
Okay, I got it. Okay, thank you.
Total resistance of this circuit.
So, because the bulb was faded, is this the same in the book as example 3 figure? On the book?
Is it the same?
What page?
Same on page 4, 5. On example
Well,
three.
if it looks the same, then it is the same.
Because the 12 was faded, I thought it was like 4 amps. So I thought it was,
Does
We're on
it,
question number 4, right?
yeah. thought this was the same.
It's the same as this.
See a B?
Not enough information, they don't give you the amps or,
What's the total
they still
resistance
wanna know
of
the
that circuit?
resistance, so you have
All
all,
they're asking for is the resistance.
Okay,
See,
well, you're gonna be 100% sure of this.
space.
It's a parallel circuit and they're all the same, right? I know it's hard to read, but they're all 12. Is that why you were asking for the same as this?
This one right here, 'cause it's 3.
Yeah,
12.
1, 2, 3, 4. You got 4 12-ohm resistors, right?
Yeah,
All you have to do is divide 12 into 4. What do you get?
4.
Tres.
No. That would be 16. Divide 12, 4 into 12. How many times does 4 go into 12?
How many times 4 goes into 12? Is
Tres.
Three.
it 3?
One of those tres.
4, 8, 12, 3.
3. So
3 ohms.
it's 3.
You can divide the number of legs by the resistance, so it's just, okay? Total resistance of that circuit is 3 ohms. Anybody not get 3?
that's 4.
You got 4?
Oh, I thought you meant question 3.
Oh, no. Question 4. Question 3 we did, right?
Yeah.
Okay. Okay. Number 5. Take it away, George.
The sum of the voltage drop in a series circuit equals the source voltage.
Source?
You said that like you're not sure.
Huh?
You said that like you're not sure. Some of the voltage drops in a series circuit is equal to the source voltage, yes.
It was like a little bit 50-50.
What's that?
Like 50-50.
I didn't hear you.
It's like 50-50.
Wasn't completely sure.
Yeah, it wasn't.
Oh. Yeah, some of the voltage drops, meaning if you add all the voltage drops together in a series circuit, it's gonna equal whatever the source voltage is, okay? Okay, number 6. Let's see how you did on this one.
C.
I use some context clues.
I couldn't get it.
Can you
I guessed
what?
A. I guessed A.
You guessed A?
Yeah.
Okay.
It's C.
Did anybody actually figure it out?
No.
What is it?
C. 2.5.
C?
I added them up and then
All you
divided
gotta
12 volts
do,
by 30.
it's still Ohm's law.
Yeah.
12,
Divided
8.
by 30.
What is 8
shit.
into 12?
What happened to the 10?
Huh?
What do we do with
We're
the 10?
doing them one at a time. This is
Okay.
a parallel circuit.
8 doesn't go in
Yeah,
there.
it doesn't go into 12 even.
That's
It does,
It does.
1.5,
Oh,
Okay.
I've never even seen it like that. We didn't even go over something.
12, 10, what is it?
1.2.
1.2, 12,
1.
1, 3.7.
Uh-huh.
Wow. I just added them all up and then divided them by 12. I think it was the other ones.
education.
I guess that's series and not parallel. I don't even remember going over something like this one. Unless I wasn't in the classroom.
No, we didn't.
Yeah.
I'm not good with decimals.
I'm alright, but again, I just added them all up. Did we go over something like
You
this?
can't add them up because it's a parallel circuit.
All I knew was that there
But you got
were
2.5.
3.
Yeah.
Wrong answer.
If you divide 12 by 30, I know I got it wrong, but I'm saying if you divide 12 by 30, you get 2.5. But what I'm saying is I added them all up and then divided. I didn't do them,
Yeah.
you know,
Oh,
the way
But
he
since
did.
it's a parallel circuit, you can't add them. You have to figure out the current for each one of them and then divide it by, or divide each one by 12, right? 8 divided by 12, 10 divided by 12. So you got 1.5, 1.2, and then 1 comes to 3.7 amps. All right. Number 7.
Tiffany.
Oh, that's me. I don't even know if I got this right. A series circuit has 2 10-ohm bulbs. The third 10-ohm bulb is added in series. Tech A says that the 3 bulbs will be dimmer than when only 2 bulbs are in the circuit. I don't think that's true at all. Tech B says that the current in the circuit will increase, which is
Yeah.
not right because it stays the same. So I
Okay, see,
said
you're,
B.
you're doing good because you were thinking. You know that the current is not going to change because it's a series circuit.
Yeah.
So B is wrong, right? The current's not gonna increase or decrease because the current is the same in a series circuit.
Right.
What else do you know about a series circuit? You have 2 10-ohm bulbs and you put a third one in there. What's gonna happen? Now you have a circuit with 30 ohms.
Uh-huh.
Are they gonna be as bright as they were before?
Yes, I mean, it just keeps going, it's just a series.
No.
You're adding another 10 ohms of resistance.
Oh, yeah, huh.
All of them are gonna be dimmer.
Even if the voltage is the same?
Yep, because you added another 10 ohms of resistance.
Higher
It's a series
resistance,
circuit,
more
it only has
resistance.
one path for current to flow. A, yes. 3 bulbs will be dimmer than the 2.
Okay.
Current won't change, so B is wrong, A is correct. Number 8.
I was half right.
The amperage in a series circuit is the same everywhere in the circuit.
Yes, 8 is A. The amperage is the same anywhere in a series circuit. That's another thing that tells you that this is wrong. This guy says the current will increase. No, it won't.
Number 9, in a series circuit, total circuit resistance is equal to the sum of the resistance of all loads in the circuit. Is it A?
It is not A.
Isn't it?
I'm sorry. Wait a minute.
9A?
Okay, let's reread this. Tech A says the sum of voltage drops in series circuits equals, yes, he is right. Technician B says the current or the amps varies depending on the value of the resistance in a series circuit.
So it's A.
It does not, right? It's just A, right?
Wait a minute, are we on 9 or 10?
I'm confused.
I'm so confused.
Are we on 9 or are you talking about 10?
Did I skip one?
Yeah, 9. What is 9?
I read 9. What is 9?
I don't know where I'm at.
You read it?
Okay. So are we on question 9?
Yes.
Yeah.
In a series circuit, total resistance is equal to what? The sum of all the resistance or loads in circuit, yes. Okay. Sorry about that.
So 10 is technician A only?
Yeah, because technician B says that the current varies depending on the value of the resistance in a series circuit. It does not.
You gave us the answer.
I know. All right. 41B, let's see what we got for B.
Technician A says the electron calculators have a memory function that can be used to calculate resistance, current, and voltage values for parallel circuit. Technician B says to separate components of a series parallel circuit to simplify calculations. Which technician is correct? Both of them?
Okay. Hopefully everybody's paying attention because just because you're not reading the question doesn't mean it's not going to be on the test that's in front of you tomorrow, okay?
I seriously missed it. I did, I was putting my test away.
Electronic calculators do have a memory function that can be used to calculate resistance, current, and voltage values for parallel circuit. Tech B says separate components of those can be simplified to make the calculations easier.
Both.
Okay, both of those guys are right.
Series circuit, total circuit, resistance is equal to the
Can't
sum.
hear you.
Question reads,
Both.
in a series circuit,
Both of them.
total resistance is equal to the sum of all the resistances, is that right?
Yes.
Does the current flow the constant at any point?
Yes.
Yes.
Okay.
2 light bulbs are wired in series and 1 bulb burns out. Technician A says that the other bulb will still work. Technician B says that the current will increase in the circuit because one electrical load resistance is no longer operating. Which technician is correct? Neither.
Neither.
They're both wrong, aren't they?
Yeah.
Okay, good. Okay, we're getting somewhere here. It's a series circuit. If one bulb goes bad, they all go out, okay?
But in a parallel.
Will the
if one
current
goes
increase?
bad-
No. I'm sorry, what?
I'm sorry. In a parallel, if one goes bad, the others will still work.
Yes, that's why they were carved that way. Otherwise, if you lost, like, say, one taillight bulb, all of your park lights, your taillights, everything would go out. That would be a stupid way to do it, wouldn't it? We did this one, 3 ohms, right? The amperage in a series
Hey,
circuit
we did that one.
is the same anywhere in the circuit. Number 6,
Current flowing into each junction of parallel circuit, bringing the circuit flow at the junction. Oh, we did that one too, isn't it? Equal?
Equal.
Oh,
No,
no,
that's
we didn't
different.
do that one. The current flow at the junction on the opposite end of that branch.
See,
Yeah, equal.
No, it varies. It varies.
It's a parallel circuit.
The current flow at the junction on the opposite end of that.
Doesn't it vary?
None.
Or is that series parallel?
we're talking about the current flowing into each junction of a parallel
The
circuit.
total resistance
It
of a
could
parallel
vary,
circuit bulb is less
right?
than.
Yeah, I told you it's equals.
Oh, yeah, it's the same. in
Okay.
each leg.
A series circuit that has 3 resistors of 4 ohms each. The voltage drop across each resistor is 4 volts. Technician A says that the source voltage is 12 volts. Technician B says that the total resistance is 18 ohm. Which technician is correct?
8.
4 times 3 is 12.
There's 3 resistors of
Drops
4
4,
ohms
so
each.
that's
4 to
back down.
The voltage drops across each resistor is 4 volts. Technician A says that the source voltage is 12 volts.
No, it's more than it's 18. Well, no, they're wrong.
Both are wrong.
They're wrong because 3 resistors at 4 ohms, 3 times 4 is 12. So we know B is wrong because it's not 18.
The series circuit, right?
Yeah.
You know the voltage drop across each resistor is 4 volts, right?
Yeah.
3 4s is 12, that's gonna equal the source voltage, right?
Yeah.
Okay, he says the total resistance is 18 ohms. 4, 4, and 4 is not 18, is it?
No.
It's 12. So it's just A, right?
Yeah.
Okay. Okay. Anybody that does not understand that?
2 bulbs are connected in parallel to a 12 volt battery. One bulb has resistance of 6 ohms and the other bulb has a resistance of 2 ohms. Technician A says that only the 2 ohm bulb will light because all of the current will flow through the path with the least resistance and no current will flow through the 6 ohm bulb. Technician B says that 6 ohm bulb will be dimmer than the 2 ohm bulb. Which technician is correct?
Well,
Neither.
A is wrong, right?
Neither.
Exactly. A is an idiot.
Yeah.
No current will flow through the seal bulb bullshit.
Yeah.
Okay?
So is B?
Technician B says the 6 ohm bulb will be dimmer than 2 ohm.
No.
Yes or no?
No, because that has higher resistance, so the 2 would be right than the 6. Oh wait. Yeah.
Keep thinking.
Will light. Tech A says that only the 2 ohm bulb will light because all of the current will flow through the path.
Technician A is an idiot. That is not true. Okay?
So it's technician B.
No, oh, there's B.
Is it neither?
B says that the 6 ohm bulb will be dimmer than the 2 ohm bulb.
Probably, yeah.
That's higher resistance.
Higher resistance, less current's gonna flow through it.
Higher resistance, less.
It's gonna be dimmer, right? 2 ohm bulb's gonna be brighter.
Tech B.
And we can test that theory tomorrow. A lot of, like taillight bulbs have a taillight and the brake light all in one bulb. It's two filaments, right? Two different resistances on them. We can put 12 volts to each one of those and ohm meter and test them. We can do that tomorrow. And you can see, same voltage, one side of the bulb is gonna be bright, one side of the bulb is gonna be dim. This is because one has a higher resistance than the other lower, whichever way you look at it, okay? Wait. What?
I still got
So-
6 more chapters.
It just reminded me, the other day when I left, there was a car in front of me, no brake lights. Like,
Mhm.
none. No
Okay.
top, no bottom,
Okay?
at all. What was that? Is that a fuse? Is that, like, what is that?
How would you figure that out? Here's what you would do. You'd figure out, obviously, what kind of car you got, right? Then you would look up the electrical schematic for the taillights. You would find out, does it have a fuse for just the taillights? If it does, that's the first place you're gonna go. Okay? If it has a fuse on that circuit that works more than just the taillights and something else works, it's not gonna be the fuse. Sometimes what happens, believe it or not, because people don't see the back of their car when they're driving, sometimes one bulb will burn out, and they don't know. Nobody tells, if nobody tells them, they don't know,
Right.
right? How often does somebody say, hey man, you got a brake light out or whatever, because you don't know, you can't tell when you're driving the car, right? Well, a few months later, 6 months later, whatever, the other one burns out. Now you got no brake lights. You might have the third stop lamp, the high mount stop lamp. It's possible that they could all go out and they burned out, you know, periodically over a couple of years' time, and nobody ever told them, they just don't know. There might be nothing wrong with it, except it needs bulbs. It just depends. Could it be a fuse? Yeah, if there's a fuse for just those lights. So
So,
normally, it's gonna have, there's something else gonna be on that circuit that doesn't work as well if it's a fuse.
okay, so you're saying not to do the bulbs first, to check the fuse first in that case, in a case like that?
Check for
The
bulbs.
first thing I would do in that case is check to make sure the bulbs are good. If they are, then you got a fuse or a wiring problem.
Okay, bulbs,
That happened to me one time at night. I was driving and the car in front of me had no taillights.
Yep.
I'm assuming his light turned not on. He just doesn't know how to turn off
Yeah.
the lights. And then he came to a full stop. And then I'm waiting for the brake light.
Yep.
I'm getting closer and closer. I'm like, oh shit. I'm hitting my brakes and they're like, no, taillights are not working.
Yep.
Did you let him know?
Nah, I just go fast.
wow.
See?
I was about to say that.
Wow.
See, look though, look. I do that now because I tried to do that. There was this woman, her brake lights were out, and that same situation happened to me. I drove up past her at the next light. I was like, "Hey, your brake lights are out." She said, "Mind your motherfucking business." She thought I was trying to talk shit. I'm like, "I'm trying to help you so you don't get a ticket."
I'm not trying to
Some people are just so rude. Like, you try to help somebody out, and they go,
Cause she on the
mind your
phone,
business,
I
asshole.
don't know you. I'm trying to help you out. You know what? I hope you get a ticket and can't pay.
I don't know the person. If I don't know people, I'm like, good
But
luck
at the
with
same
it.
time, you don't know what somebody's going
Only my
through.
family members. If I
Yeah.
see like, hey, you
Somebody's
like,
done that to me though. They let me know my brake light was on. I was like, "Oh, appreciate you."
Yeah, yeah.
So I did say,
you
you know
would,
what?
but
Fuck you.
Okay.
I get a flat tire and can't change it.
Who's gonna answer number 9 for us?
I can't see
12-volt battery is connected to a series circuit with 3 resistors of 2 ohms,
You with us, Terrence?
4
it.
ohms,
Six,
and
Sure.
6 ohms.
2, 4, 6.
How much
Give us the answer to
current
question number
will
9.
flow
then.
through the circuit? 2 ohms,
Turns
4
Three
ohms.
resistors of,
This
are they
is a
saying 3
series
resistors of 2, 3 resistors
2,
of
4,
4,
6.
and 3 resistors of 6?
That's 12.
There's this is 2, 4,
1 amp.
Oh, okay. So just 2, 4, and 6. Okay.
Did 3?
3? Okay.
How'd you get it?
2 plus 4 is 6. 6 plus 6 is 12.
What kind of circuit do we have?
Series.
Series.
Right?
12 divided by 12.
What's the series circuit law as far as resistances?
Don't you add them up?
Times 4.
You
Add
add the
up the
ohms.
ohms.
You add them together, right?
Right.
Right?
And resistance.
Can you add 2, 4, and 6? I hope.
A.
Yeah.
What is it?
Well,
OB1.
It's 12, right?
Yeah.
So if you have 12 volts and 12 ohms,
It's 1.
you got 1 amp, right?
Uno.
Okay.
So what do you have to do if you have to divide? What does it have to say?
That'd be
Series
a-
is, I have to add them together. What it,
Ohm's law applies to any circuit. okay? In order to find resistance, you have to do this. In order to find current, you have to do this. In order to find voltage, you have to do this. And that's what each one of these means, right? All right, Tim.
Technician A says the sum of the voltage drops in a series circuit should equal the source voltage. Technician B says the current amp varies depending on the value of
we did
the
this already,
resistance.
didn't we?
Both.
How would you even say that? Amperes?
Amperes?
Amperes, yeah.
Amperes?
Yeah,
Oh.
but we just typically
Yeah,
say
just
amps.
amps.
Yeah. Okay. All right. Okay. Next chapter, 42.
My stomach hurt.
42. 42 deals with meters, I believe. Circuit testing, digital meters.
Chapter quiz, 4
Okay. 4 for more, okay.
He's so tired of the chapter quiz.
Okay.
Especially the first two are A.
Answer the first question is what?
The amperage in a series circuit is A. Oh, that was right.
Yeah.
The sum of the voltage drops in a series circuit equals the
Ohms? No. The sum of the voltage drops in the series circuit equals the
C.
source voltage.
You gotta let us know what we write out there.
I'm sorry, where are we at?
I'm a
Two.
One is A, two
one
is C,
A,
right?
right?
Yeah,
Two is C?
yeah.
Okay, just making sure. I'm an overthinker. Unless you say yeah.
Three is
I'm thinking
A.
it's still
We-
wrong.
We've done all these.
Oh, we did all of them?
4
4 is what?
B.
4 is what?
Oh, 4 is neither.
No.
A series circuit has 3 resistors of 4 ohms each.
Can you multiply 3 times 4, hopefully?
12.
What do you get, 12?
Mm-hmm.
So you have 12 ohms and 12 volts, right? We don't really care about that, he just
Yeah,
says the voltage
A is
drop
right.
increase
Oh, so it's A.
across each resistor, yeah,
So the A?
Yeah.
We did this one.
we did.
I can't remember, man.
This guy says total resistance 18 ohms, well, you can't add 4 3 times and get 18.
Oh, yeah, this one would be
5 is B, yes.
Calculate the total resistance and current in a parallel circuit with 3 resistors of 4, 8, 16 ohms using any one of the 5 methods calculator suggested. What is the total resistance?
Okay, we're not gonna worry about that. It's too time consuming and we're not gonna worry about that one. Number 7, a vehicle has 4 park lights, all connected in parallel, 1 bulb burns out. This is how your vehicle's wired, right? Tech A says that this could cause the parking light circuit fuse to blow.
No.
No. If a bulb burns out, is the fuse gonna blow?
No.
No.
so is it B?
Technician B says that it would cause a decrease in current in the circuit.
No.
No.
No. Okay. Because resistance is controlled lower motor speeds, just an example of a what?
Vehicle's resistance to control the lower motor speed. This is an example of a.
We haven't heard of some of these.
I don't know that they showed that in here. I think that's a series parallel circuit, actually. I don't know that they show this in here, but. Yeah, I don't think they show that example in here, the blower motor.
It might be one of those like green or blue boxes, like the
Might be, yeah.
customer complaint.
Okay, a circuit has 2 resistors in parallel. Each one is 6 ohms.
12.
No, parallel.
Oh.
2 resistors are 6 ohms. What is that?
2 resistors 6 ohms. That's,
becomes 3.
yeah.
It's a
3.
parallel circuit.
So that'd be 6B.
Circuits connected with a single resistor of 6 ohms to form a series parallel circuit. What's the total ohms?
6. No. Wait, I'm not reading the whole thing.
A circuit has two resistors. The circuit is connected to a single resistor of 6
It's
ohms.
18.
It's easier looking at a diagram.
It is. 2 resistors in parallel, each one of them is what? 6 ohms?
Yeah. Okay.
So let's draw it.
2 of them in parallel, 6 each, divide 12 by 2. That's 6. So each one would be 3 if you divide them by 2 each.
What did it say, they were 6?
Yeah, 6, then 6. You divide both of those by 2, that's 3. Add them together, that's 6.
So what do we got here? We got 3 here, right?
Yeah.
Okay.
Oh,
And
shit,
now,
I'm way off.
it has a single resistor of 6 ohms in here.
Can you see that?
6? So it's a series circuit now.
Yeah.
So all you gotta do is add the 3 and the 6, and you get
9.
9, right?
That was way more difficult than what it should have been.
All right.
I'm gonna start drawing diagrams.
Oh, we do have one more, right?
In a series parallel
It's
circuit,
D.
how is
The
the
D,
total
right? None of the
resistance?
above, yeah. Yeah, I think we did that one.
None of the above?
None of the above. All right.
What was 8?
We didn't do 8.
8 was B.
8 and 6, we did, how do you know it's B? You said it?
Say.
I think it's a series parallel circuit, but I don't think that's
All right.
actually in
There you
here.
There you go. B. Did you figure out 6 at all?
6?
That was the one with all the numbers you had to add? Or
We can, but
I too much time.
I'll figure it out later.
Are we going to do, chapters 44 through 47 tomorrow morning?
We have to go to 47 tomorrow, yes, by tomorrow. We have to get to 47. So we're gonna do 42 now. That'll leave us 5 for tomorrow. We can get through 5 tomorrow. We're going to discuss how to safely set up a fused jumper wire test light logic probe. Digital multimeters, inductive ammeters, diode check and frequency. Prefixes used with electrical units, how to read the meter. How to safely use a digital meter, read voltage, resistance, current. Compare it to what it's supposed to be. Fused jumper wire is used to check a circuit by bypassing a switch to provide power or ground to a component. The reason you use a fused jumper wire is in case you have a short or something that could cause it to burn. Should include a fuse, a couple alligator clip in, good quality insulated wire. Can supply a power or a ground. Kind of looks like that. Test lights. Everybody used a test light before or no? Yeah? Okay. I'll bring you a test light tomorrow. We can do some testing and stuff like that, all right? On power test lights, simply a light bulb with a probe and a ground wire attached, all it is. Use 12 volt test light. Use to check electrical power. You can also use it to check grounds. A high impedance test light means it has a high internal resistance, therefore it draws a very low current in order to work. If you're going to use a test light to check to see if this wire had power on, let's say this was a power wire, and let's say it was green. And you took your test light, turned the ignition on, because a lot of times you have to turn the ignition on in order to get power to something. Put the end of the test light alligator clip on the ground somewhere. Poke that terminal, don't poke the insulation, the terminal, okay? You don't want to pierce the wire.
I have a question on the ignition part. You know when you turn your car, you first turn the key, that on your radio, and then as soon as you turn it again, it owns everything, your windows and everything. So like, what's the point of it? Like the point of like turning the first time and then going to the radio, is just the radio turning on, turn it again and everything turns on. You know, you turn it one more time.
called the accessory position. Okay?
So if you don't-
So some cars do have that, for where you turn the key to like one click, and that's your accessory position.
Yeah.
That means the radio is gonna play and do things like that, and then you turn it to the next one, is actually the on position, where everything works. And then the next one is obviously the momentary for the start.
So what
Okay. That's an accessory position.
Is there any meaning to it? Or is it just?
Yeah, if you wanted to sit in your car and listen to the radio without everything being on, that's what it's for.
It's better to turn it on, because you're just wasting battery, you just turn on the accessory, right?
Well, you're not wasting as much battery power, because it only powers a certain amount of things, instead of the whole car.
Cause I thought if you on that one specifically, it's just. if you
So a
on
lot
the
of
car-
times the ignition switch will have your off, right? And then what they call accessory mode, and then on, where everything is on. And then your start position. Okay?
Isn't it better to leave the car on, start it, because the generator's charging the battery, so you're not.
It is better to do it that way, yeah, but if you didn't want the engine to run or anything like that, you know, but yeah, I mean, certainly you could sit there and listen to the radio until the battery went dead. But, sure, it's better to start it. Yeah.
How long can you keep it in that?
Depends on the condition of the battery. If you got a good battery, you probably listen to the radio for a couple hours without any problem.
Alright,
But if your battery was marginal, you might go dead in a couple hours.
alright.
Okay, we can actually do this for real, okay? As far as test light testing, stuff like that, I'll bring one in tomorrow, we can actually get tested. So all this is testing fuse. You know a lot of these fuses have test points on them, right? The little metal things on the top of them, which we'll do that again. We'll do that tomorrow as well. So this is just telling you test light can be used to check opening the circuit. Note that test light is grounded in a different location than the circuit itself. Obviously no power there. Why? Because this wire is broken right here, right?
Yep.
Okay. So let me ask you this, is this a series circuit or a parallel circuit?
Series.
No, I don't know.
If it was a series circuit, none of the bulbs would work, right?
Right.
Because this wire is broken. If one bulb goes out, they all go out, okay? They're on the buddy system. One of them goes out, they all go out. Okay, we don't care about that. Test light is out, what's wrong? Oh, the light is out, I'm sorry. Circuit is bad, bad fuse, no power. Again, we'll test this tomorrow. Okay, anybody ever heard of a logic probe? Kind of like a test light. It will light up red if it's polarized, right? Meaning if you put the ground on ground and the tip on positive, and if you switch it, it'll light green. I'll bring in one tomorrow again, we can watch that in action as well. Logic probe must be first connected to a power and ground, such as a vehicle battery. It's easier to demonstrate this than it is to, you know, look at it from here, but, you know, I'll bring in the stuff tomorrow to do that. So I don't forget, I'll put it on my notepad.
So, I have a quick question.
Yeah.
Do we have a scan tool for electrical?
Do we have a what?
Scan tool for electrical?
Scan tool for electrical.
On the vehicle?
Do you have tools for, do it like?
Yes, they have. I'm asking if they have a specific scan tool that you can use on a vehicle to check electrical fault.
Uh-huh.
That's
Do
not,
we have that?
Do you have the tool to do it, you mean?
No.
do they have it? He's talking about.
I'm not sure what you're asking me.
He's talking about the coder.
The
what is
code?
it? The OB, the OB.
Would there be a code that there's an electrical problem?
Yeah,
Yeah.
Oh,
yeah.
could you have a trouble code for electrical problem? Is that what you mean?
Yeah.
You could. Sure.
Okay.
Sure.
Oh, you can check it like that, I didn't look at the fuse, right?
What's that?
You can check it with a scanner instead of checking the fuse tube. So if something runs out, like your lights in the back, all of them,
Mm-hmm.
you can't put like a scanner tool in it, see if like it gives you a code for that?
It wouldn't
If
be,
the lights are out?
Probably not.
If there's
Some
no
European
electrical-
cars will do that, like they'll even light something up on the dash saying your tail lights out or something like that, but for the most part, they don't. Yeah. Scan tool is not gonna be that helpful for, like a bulb that's out or something like that, but. All right, let me, okay. Digital multimeter, that's what you see on the table there, okay? They call it a DMM or DVOM, commonly used terms for high impedance multimeters. We will use that tomorrow too. Means it has an electronic internal resistance that's high enough to prevent excessive current draw when you test a circuit. Most of them are 10 mega ohms, okay, or 10 million ohms. DC voltage, we'll do that too. Measuring resistance, we'll do that. Again, we'll do all this with the meter, okay? So again, I think it's easier for you to see it done and do it yourself. But that's part of what we'll do tomorrow. This is also the meter you see on the table. This tells you what each one of these little things does on it. Each one of these little ranges. This was old and not so happy anymore, but it's the same thing, okay? Right, has all the same functions, does the same thing that this does, right?
Did you use that back then?
What's that?
Did you use that back then?
Did I use it?
Yeah, did you use it?
has it always existed? Like, is it new or has it always been around?
I've had that for probably, I don't know, 35 years, maybe 40.
That's when it came out, or did it?
They've been out forever.
Okay.
Yeah, I mean,
You use it a lot?
oh yeah. Yeah, I'll bring in another one tomorrow that too, that's got the inductive pickup for measuring amperage, which we'll get to as well. Okay, so this is just what the symbols mean on it, okay?
We're just doing a tour.
Oh!
Pretty.
Oh, okay.
I'm just telling them all of this stuff about you.
Oh, why would you do something like that? That's awful nice of you. Too. Okay, so these are just the symbols that you'll find on the meter. AC just means alternating current, right? DC, direct current. V is voltage, MV is millivolts, amps, milliamps, percentage, ohms, kilo ohms, mega ohms, hertz, kilohertz. And the bottom one is milliseconds, or like pulse width or something like that. We'll actually go outside tomorrow, do a little field trip out of the parking lot,
Field trip.
do some testing with a meter, stuff like that, okay? Typical auto ranging meter, that means it will automatically select the proper scale to read the voltage being tested. Scale is selected, usually displayed on the meter face. Meaning this is a 0 to 4 volt scale on this. So this is going to be 3.865 where you see the little. If the voltage exceeds what's on the scale, the meter will auto range up to the next scale. As you can see, let's say this was like it was before on the previous slide where it was just 0 to 4 volts and you were testing 4.65 volts, it would auto range up to the next one. This is 0 to 40 now. Okay, that's what it means by auto ranging. And we'll do that too. Again, it's more fun to actually do it than it is to look at it, right? You learn more by doing it. Let me put this on my, just took bring to you. Okay.
Quick question, will we need to know the symbols, the common symbols and abbreviations? Will we need to know that for the test?
It would help us.
You will need to know what each one of those means. I mean, they're pretty simple.
I don't know the millivolt or the.
Okay,
milli-
if you look at the symbol, AC is obviously AC, alternating current. Everybody's familiar with AC, DC, right? Right. DC, direct current. I'm not talking about the band. V is for voltage, MV millivolts. The big A, amps, right? MA is just milliamps, okay? Percentage, ohm scale, you know about the ohms. The other two are just K and mega, meaning 1,000 ohm or million ohm. That's all that is. Hertz is just frequency. Kilohertz is, again, frequency times 1,000.
I got a question. It's both on and on subject. Do you know why they chose K for 1,000? Like, why does K abbreviate 1,000?
Kilo, 1,000 means 1,000.
Oh shit, I didn't know that.
Yeah.
That's from the old times. Where
Uh-huh.
The first thing that popped in my mind was Pablo Escobar.
Of course it did.
Yeah. And I'm Colombian.
Must and ohm.
Okay, why must an ohm meter be connected to a disconnected circuit or component?
I must know me to reconnect. Oh,
Meter provides power for whatever being tested. Again, we'll test all this stuff tomorrow and I'll show you how all that works, okay? So what's going on here?
testing the horn.
They're testing what?
Horn.
Horn.
What are they testing though?
To volt.
Okay, this is your horn, right? Your
Yes.
horn got two wires, power and ground, right?
Yeah.
This is the schematic symbol for ground, right?
Yep.
So this is the power wire, right?
Yep.
So what did they do? They took the power wire off of the horn
Mhm.
and they connected the meter in series with it,
Okay.
which means the current flowing through the meter to the horn, this is measuring how much current flow there is to that horn.
Okay.
There is 5.6 amps flowing to that horn when you hit the horn button and the horn honks. Okay, so that horn's drawing 5 amps.
So you could take these out and plug them onto the, like the horn and.
Yeah, so you could open any, well, in order to check amperage, you have to move this over to here.
Yeah.
You would have to put this on the amp scale, and then you could open the circuit somewhere and hook this in series with it, and it'll measure the current flow through it,
Okay.
okay? There's also an easier way to do it with an inductive pickup, which I'll have in my other meter I'll bring tomorrow.
Gotcha. Don't forget wrong.
All you're doing is you're putting the meter in line with this power wire,
Gotcha.
and then activating the circuit. I mean, in this case, you would just have to hit the horn button on the steering wheel, right? And then it would, obviously the horn's gonna work, because it's gonna flow right through the meter. Horn's still gonna honk. But it's gonna tell you what the current draw of that horn is, or whatever you're testing.
What if your horn doesn't work and press it? It could be the issue.
Okay, so let's say, we use his example. Let's say your horn doesn't work, and you wanna check, well, actually, probably first thing you do is check the fuse, right? It's always kind of the basics, right? Let's say the fuse is good. You hit the button on your steering wheel, horn doesn't work, okay? Easiest way to check this would be to take your test light, put the little clip on the ground, poke that wire right there, the power wire, and then have somebody hit the horn button. The test light lights, the horn's bad. If it doesn't, you got a bad connection somewhere in here, okay? If it didn't work, you're not gonna get anything here if you're doing a current draw test on it. Okay? Okay. We don't, okay, we'll go through the inductive one as well. This is, this one measures current flow without physical contact. It just has a inductive clamp on it. You just put it over the wire, it'll measure the current flow through that wire, rather than opening the circuit, okay? It's gonna have a little clip like that. Inductive ammeter. Anyone like, we're gonna bring in tomorrow, looks just like that one in that picture. You just open the jaw, put it over the wire, put it on the amp scale, energize the circuit, and it will give you the current draw for that particular circuit.
I called a technician to come take a look at this.
Okay, cool, thank you.
Okay, they'll be sure.
Yeah, it just kinda went dead, I don't know what
Yeah, I
happened.
don't know if it's the battery, but they were up
Yeah.
on the roof doing some maintenance,
Yeah, I
so
know,
who
that,
knows?
that's when it went out,
Yeah.
yeah,
Okay, all right, thanks.
yeah. Okay, how is an ammeter connected to an electrical circuit?
That.
Hmm?
That's the ammeter, right? That's it, right?
They take the things, the
The things.
positive, negative, between one side and the other side, blah, blah, blah. There you go. There's your
What do you think?
series.
It's a simple answer.
Wow.
It's connected in series with the device wherever you're checking the current on. Again, we'll do this tomorrow, so it makes it easier to understand. Over limit display does not mean the meter is reading nothing. We'll go through that tomorrow. We talked about that a little bit before. Typical digital multimeter, when you turn it on, the thing is gonna say OL on it. It just means that it's out of the meter limits because you're not testing anything, okay? Doesn't mean there's nothing there. And we can do some diode checks as well. Diode is basically a one-way check valve, electrical check valve, basically, to put it in simple terms, okay? Allow current flow one way, not the other way, unless it's a Zener diode, which has a breakdown voltage, which we'll get to later. Duty cycle, that means the amount of time or percentage that a signal is on compared to being off. So, I'll give you an example. Let's say you're a cooling fan on your car, okay? When your fan comes on, it's not necessarily on at full power, full voltage, doing everything, right? Typically, it's what they call pulse width modulated, and it has a duty cycle. So let's say the PCM wants to turn the fan on, but it doesn't need to be full speed. Let's say it turns it on at 50% duty cycle, meaning it's on half the time and off half the time, but you don't know it. It's still spinning. It's just not full speed. It's just running at a slower speed, okay? Obviously, the more the duty cycle, the higher it's gonna do if it's a fan, right? 100% would mean it's on full blast, right? Okay? We've talked about frequency before, how many times per second a signal changes. Checking a diode will do that too. So this is what's gonna happen. There's actually a spot on the meter for diode check. See how you got nothing one way, and then you switch the leads, and you had about a half a volt. Okay, that's the typical bias voltage for a diode, but we'll do that tomorrow too. Measuring frequency. Electrical unit prefixes. Always check the base of the meter, make sure you have it on the right, right scale for whatever you're measuring. Prefixes can be confusing because most digital multimeters express values of more than one unit. Especially with auto ranging, we'll get to that too. Okay, everybody familiar with mega, kilo, base, milli?
Yes.
Okay. That's in the book as well, there's a chart for that. How to read the meter. Select the proper unit of electricity for what's being measured. You're measuring DC volts, select DC volts, right? So, it's all on the meter, so if you're looking at DC volts, you would see a V and then kind of like that for DC, okay? If you're measuring AC volts, you would put it on the scale, looks like that. It's gonna give you like an AC sine wave, right? If you're gonna check ohms, you know that's the omega symbol, right? If you're checking amps, you're gonna put it on the A. Checking milliamps, whatever it is, just like on that scale we saw. The only difference is if you're checking amps, you have to take the red lead and move it over to this other spot for checking amperage, okay? more fun stuff. Let's see, this is talk about the current voltage resistance. We'll play with all this tomorrow with the meter. When reading AC signal voltage, a true RMS meter like the Fluke 87, that's actually an 88, I believe. The 87 is actually, I think, better for automotive. Okay. This meter shows 0.52 volts AC. Notice that the 0 beside the 5 indicates the meter can read over 100 volts AC. A resolution of 0.1 volts. If you're measuring something on a hybrid vehicle, make sure you have the category 3 for 1000 volt, or Cat 3 as they call it. So we'll go through all of this, so you're gonna be better off looking at it than you are seeing it here. So let's just do it. Yeah.
Two things, or not two, one. So I changed the oil and transmission fluid on hybrid for the first time.
You did.
You changed the training fluid in a hybrid? How did that go?
Not training fluid, oil fluid. It was,
Oh.
I don't know what the heck it was. But we had to put the shit in lowest gear. Like went to maintenance mode or some shit. It was weird. Like we had to go to somebody else and ask them how to go about doing that.
What kind of car was it?
It was a Honda. Actually, I think it was a Honda. I think it was a Honda. Hondas are fucking weird. We had, I don't know if they're all the same, but this one wasn't. But we had one that like you have to pop the the filter off and take out an actual filter, replace O-rings. Like there was a rubber O-ring and then one for the actual like capsule looking thing.
Really?
And then you gotta shove the filter in there and then put the capsule on after, so before it falls out. And then
Really?
yeah, it was weird. I've never seen an oil filter like that.
Have you ever seen an oil filter like that, Ron?
Wasn't really paying attention, but I'm gonna say probably not. I haven't worked on a ton of hybrids, but, so I don't know. about back here?
Okay,
You sure?
yeah,
Where are you at?
just looking over my answers.
Okay. Did you already answer them all?
Huh?
Did you already answer them all?
Not the backside, just the front.
Not the backside. Where does the backside start? With what number?
8,
8, so you're on 8.
yeah.
Okay. You haven't answered 8, 9, and 10 yet? Good to go.
Yeah.
Yeah.
Number 1.
A meter used to measure amps is called an ammeter.
C. Everybody get C.
Yes.
Anybody not get C? Remember I told you at the very beginning of that, they don't use the P when it's being described as a meter, okay?
Okay.
No P, like in your swimming pool.
Number 2, the internal resistance of any meter is only effective if the meter is set on the ohmmeter scales. C?
No, that would make sense. I see how you got that.
Yeah.
Resistance, ohm, right? Yeah. Yeah, I get where you were going with that, but that's not correct.
Is it A?
Yes. Internal resistance meter is only effective when it's set to the volt scale. You'll see that on 481 under digital meters per paragraph, okay? Number 3.
When interpreting meter readings in power ranging mode, I choose both.
You took both? Okay. Note the prefix indicated and convert the meter prefix to base units if you have to. Both of them are correct.
The volume should be connected to a circuit between testing and patterns.
I'm sorry.
4 is B, right?
4 is B, yes. Parallel.
Yeah, sure, well.
Number 5. I
Yep.
put C.
You put who?
C.
C, huh?
Only when no power is flowing.
All right.
That's right.
Yes, ohm meter should only be tested on food circuit testing when there is no power flowing or the circuit is electrically open. Checking ohms, you don't want voltage present. Okay, let's see if you know how to read a meter.
Okay.
Number 6. A reading of 432 on the face of a meter set to the millivolt scale means it is 0.432 volts, just under a half a volt.
Which device illuminates a different color when connected to power or ground side of a circuit? Will it be, no, it's not that. It's not an LED light.
It's both,
Even
right?
though it was light up.
Both.
Oh, I do not see both.
So,
An LED test light isn't necessarily logic probe, so logic probe is the one that's going to change different colors depending on the polarity. I'll bring one tomorrow, you can see it in action.
So it's A.
Yes.
I did choose A, but I really didn't see both, so I really didn't back.
Oh, okay, all right.
If a digital meter phase shows 0.93 when set to K ohms, the reading means, I wasn't too sure, but I know K is 1,000, so is that C, 9,300?
I got B.
I got B.
You got what?
B.
Give me a word, I can't tell.
Bullet.
Yes.
Is B?
B?
Yep.
How
Sure
is
is.
it, according to the chart on page 481, the K ohms is,
If it's 0.93 thousand ohms, that means it's 930 ohms.
So you just move the decimal?
yeah, but you're supposed to move the decimal over
2, like
3. 1,000 is 3. 100 is 2, 1,000 is 3, million is 4. Or, now I'm confused.
So this is a 2, so you count the number, it's 2, so you move it 2. 1, 2.
1, 2, 3 would be 930 ohms.
Hmm?
Mhm.
So would it not,
If you move this 3 places, 1, 2, 3, yeah, put an O here, it's 930 ohms.
oh, okay, I did my math wrong, okay, thank you.
All right. What could happen if the meter leads were connected to the positive and negative terminals of the battery? Well, the meter leads were set to read amps. You're not supposed to do that, right?
No.
Would display OL. C.
Over limit?
More dangerous than that.
Could
Low
go.
internal fuse or
Yeah.
damage summation.
9 is A. You don't want to do that. If it's set to read amps, make sure you're reading amps. Don't hook it to volts. Which of these is safe for use in electronic component circuits?
Both?
LED, not a continuity tester.
No, continuity for electronic continuity?
Not for electronic devices, no, overload the circuit easily.
Oh. What was 9?
A. Okay, this digital multimeter is set to read ohms. The reading shown means what?
Okay.
Over limit. Wait. OL over limit.
Out of limits, out of meter limits, or this circuit is open, meaning it's not supposed to be anything. Right?
Highest amount of resistance that can be read by the meter set to 2K ohm
Can you make that
scale
bigger, please? I'm blind.
Sure.
is A. 2,000 ohms.
This should be obvious.
Yeah, 2K.
What's the highest amount of resistance that can be read by the meter if you set it to the 2,000 ohm scale? Well, 2,000 ohms, right?
When using a DMM, the black lead usually goes in which one?
DMM digital multimeter, where's the black lead go?
B?
A. COM?
What's-
Black lead, where does the black lead go?
COM.
Oh.
The common, okay, COM, all right? That's almost always where it's gonna be.
Black common is black.
Yep.
Common is black. He is. That's how I remember that.
A high
A high impedance meter, meaning high resistance.
has a high internal resistance.
Has a high internal resistance, is right. Most of them, 10 million ohms.
That's impedance, right? Impedance.
Kilohertz, is that kilohertz?
Yeah.
Kilohertz is describing what
Kilohertz.
property?
Is a unit describing
Frequency?
frequency.
Frequency, yes.
A meter is set to read DC volts on the 4-volt scale. The meter leads are connected at a 12-volt battery. The display will read OL.
Mm-hmm. Out of limits, that's what it'll do.
A meter is used to measure amps and is called.
A voltmeter.
7.
A voltmeter should be connected.
Oh shit. A
We did this
voltmeter
one,
is-
right?
Yeah, and that's ammeter. See.
See, yeah.
When
Yeah.
using the test light to probe for electrical power, the alligator clip is connected to.
Negative?
Clean metal part of the vehicle body.
Yeah, A.
You're checking for power with a test light. Where's your alligator clip go?
Oh yeah, on the negative post. There's an alligator clip.
Is a clean metal part of the body pretty
Yeah,
much
that's
the
fine,
same
too.
as the negative
So
post?
both.
It's the same, so both, yeah.
Both.
Either one.
That's A, right?
Both.
Either one.
How can a test light be used to test a ground connection? By touching both the tip and ground clip to the positive terminal of a battery. By touching the ground lead to the tip of the test light. Yeah. By connecting the tip of the test light to a good ground with other end to the positive terminal. Is this C?
You're just hooking it up backwards.
Yeah.
That's all you're doing. You can use a test light detector for power or ground.
Hmm.
Okay, you just hook it up backwards. All right, all right. We'll go over this tomorrow in the real world with the meter. Before we get to, the next chapter is going to be, a little bit more meter stuff.
So we're gonna do 43 through 47 tomorrow,
Oh, you know we are.
and then we're gonna test.
Wouldn't be a bad idea to read some on your own tonight.
So we're gonna go through 5 chapters in the morning before lunch.
C, 2 is A, we did that one. 3 is B, we did that one. 4 is C, we did that one. 5 we did not do. The testing of diodes, the multimeter set on diode check. Reading point 6 is obtained.
Is it E?
I'm sorry, where you at?